So my name is Dr. Xavier and I'm going to be discussing organic chemistry as a branch under pharmaceutical chemistry. So organic chemistry, this is the study of carbon compounds containing hydrogen and any other one or more element. For example, we have oxygen, it could be the halogens, it could be the phosphorus, you get. So the carbon compounds, when I talk about carbon compounds, I'm actually talking about the alcohols, carboxylic acids, I'm talking about the amines, you get. Those are the carbon compounds. You have the hydrocarbons, those containing hydrogen as the other extra element, you get. So with carbon has very many characteristics as carbon acting as an element. For example, we have carbon has an atomic number of 6. Atomic number is the total number of protons existing in an individual atom, you get. So that we have the atomic number and the mass number. With mass number, total number of neutrons and protons in an individual atom, you get. Then carbon, it as itself is non-metallic, exists in 3 isotopes. Carbon atoms are also tetravalent. When I talk about tetravalency, I'm talking about the valence. It has a valency of 4. Then with it also has a catenation property. Yeah. So basically, that was just a brief intro about what I'm going to be talking about. So with the atomic number, it has an atomic number of 6. Atomic mass, it has an atomic mass of 12.011 or 12.011. Then its state, carbon exists in 3 different states. The solid state, where it exists as diamond, graphite. Then in the liquid state, it exists as the carbon disulfide. Then with the gaseous state as carbon dioxide. Then that's actually the state. Then with the valency, carbon has a valency of 4. That's why it is referred to as a tetravalent compound. It has 4 electrons in its outermost energy level, therefore it forms 4 bonds, you get. So with the electronegativity, as we discussed in the advanced level, electronegativity and the ability of an atom participating in a covalent bond attract the bonding electrons towards itself more than the other elements. So the electronegativity of carbon is 2.55 as its electronegativity. So that's the electronegativity value. Then with the reactivity, carbon reacts with the elements to form covalent bonds. Then with its catenation property and the ability of carbon to form long chains of compounds, in that its tendency to form the longer chains by linking to isotopes. Isotopes, as I was explaining, isotopes, these are atoms of the same element with different different mass numbers. So how does this try come up? So with the different mass numbers are brought about by the changing number of neutrons. For example, we have the carbon 12, carbon 13, carbon 14, you get. So the changing number of neutrons. So carbon 12 has 6 number of neutrons. Then 13 has 7 neutrons. Then 14 has 7. So it keeps on increasing. You get 8, 6, 7, 8. You get. Then with the allotropy, allotropy would be the property of an element to exist in multiple physical forms while retaining its chemical properties. You get. The property of an element to exist in multiple physical forms while retaining its chemical properties. The different forms of allotropes of carbon, we have diamond, which is solid, we have graphite, we have the fluorines, then the nanotubes. Of course, allotropes are the different physical forms of the same chemical element. So these elements are the same, but and differ in their crystal structure or molecular arrangement, you get.